Lesson 11.8, Surface Area and Volumes of Spheres. The first concept we're going to look at is how to find the surface area of a sphere. Now, calculating the surface area of a sphere requires some calculus. So since we do not know calculus, we're kind of going to use an alternative way of finding out what that might be. So what you guys see in this diagram is a baseball, and you see the net that it takes to create a baseball. Now here, this is the circle that would be considered to be the circle right across the ball. So I enlarged these two so we can see it a little bit better. Okay, so here you have a three-dimensional ball. I know it doesn't look like it's three-dimensional, but it's three-dimensional. If you were to cut along these lines right here in the three-dimensional form, you would get this net right here. Now, this circle right here happens to be the radius of the sphere, or for the ball. So as you can see, the circle tends to be a lot bigger than this. So it would take at least 1, 2, 3, 4 circles, not full complete circles, but if you take a look at all of this space right here cut up into little pieces, it would literally fill up all of this. Okay, so what I did here is I went ahead and I cut these into halves, and I grabbed one of these and I cut it up into multiple little parts. As you can see, this right here represents the area of one of the circles, which is pi r squared. So altogether it takes 1, 2, 3, and 4. So the surface area of a sphere is 4 pi r squared. So let's go ahead and write that down in our journal on page 349. So surface area is 4 pi r squared. Now let's go ahead and take a look at the volume of a sphere now. So let's turn to page 350. So on page 350, let's look at the volume of a sphere. Now in the description, I'm going to leave a couple of links that I want you guys to see so that you can understand what I'm going to be doing in just a second. So in the video that you guys are going to see from the description, you will see the following. If you were to look at a sphere, let's think three-dimensional, okay? Our sphere with a given radius of r. Now, obviously, the distance from this center to anywhere on the sphere is going to be the same. So the distance from here to here is going to be r, and the distance from here to here is also going to be r. Now, if you were to have a cone with the same center and same circle and same radius, pretty much this circle is the same as this one, but the height of the cone happens to be the distance from here to here. So same height. Same radius and same height. Now, the distance from the top of the vertice to the center of this cone is going to be the same as from here to here. So the distance from here to here happens to be 2r. Now, in the video that you guys will see, you're going to notice that if you were to turn this cone upside down, fill it up with water, and then pour it into a sphere, it's going to take 2 cones to fill up a sphere. That means that two cones or two volumes of the cones, so two volumes of a cone is going to equal one volume of a sphere. So now let's start with some math here. What is the volume of one cone? So the volume of a cone is pi r squared times the height of the cone, all divided by 3. So this is the volume of one cone. So if I were to double that, this will be the equivalent to the volume of the sphere. Now, the only difference is that in this case, h happens to be the height, which is the distance of 2r. So we're going to replace that h with 2r. Now, before we do that, let's do this. I have two of the same values. So that is 2 times pi r squared times h, all divided by 3. Oops, too many 3's. So if you were to replace this h with a 2r, I would have 2 pi r squared times 2r, r, not h, 2r all over 3. Simplifying that, I would get 4 pi r to the cube divided by 3. Hence now you have the equation for the volume of a sphere. We're going to proceed to using these two equations in the following 5 examples. Now turn to page 351. At the top of page 351, you're going to be doing problems 1 and 2. At the bottom, you're going to do examples 3 and 4. And once again, the surface area of a sphere, we already said was going to be 4 pi r squared. Next, page 352. You're going to do problem number 5 right there. And once again, the volume of a sphere is 4/3 pi r cubed. Let's go ahead and start with the examples. Example number 1. It says find the surface area of the sphere. So we have two problems to do. So remember, the surface area of a sphere is 4 pi r squared. The radius is 8. All we're going to do is substitute the values in there. So that's going to give me 4 pi times 64, and 64 times 4 is 256 pi. And that comes out to be an approximately 804.2 inches cubed. Now, in part B, we're going to use the same equation. The only problem is we do not know what the radius is. However, we do know, let me fix the lighting here. However, we do know that the circumference is 12 pi. Now, we also know that that is equal to 2 pi r. That's the circumference of a circle. So to solve it for r, we're going to divide this by 2 pi. Therefore, the radius is going to be 12 divided by 2, that's 6, and pi divided by pi, well, that divides out. So the radius is 6. Now with that, I can go ahead and find my surface area. Surface area, we said it was going to be 4 pi r squared. That's going to be 4 pi 6 squared. So that's going to give me 36 times 4 times pi. So 36 times 4, that's 144 pi. And that's going to give you a total of 452.4 feet cubed. I'm boxing in both answers because sometimes they might want the exact answer, sometimes they want the approximate answer. So either one. So that's example number 1. Example number 2. Find the diameter of the sphere. They tell me that the surface area is 20.25 pi centimeters. So surface area, we already know that is 4 pi r squared. So what we're going to do is we're going to equal 20.25 equal to 4 pi r squared. Our goal is to find the radius so that we can double it to get the diameter, because we know that the radius times 2 equals the diameter. So what we're going to be doing, oh, don't forget my pi, is we're going to be dividing this by 4 pi. The pi's divide out, and I get 20.25. Okay, apparently I thought I clicked to record, but I guess I didn't, so I'm just going to re-explain problem number 2. The surface area of a sphere is 20.25 pi centimeters squared, and we are asked to find the diameter. So the surface area is 20.25 pi equal to 4 pi r squared. You divide both sides by 4 pi, that eliminates that pi and that pi. 20.25 divided by 4 gives you 5.0625, and that is equal to the radius squared. Take the square root of both sides, and you get 2.25. Now, when you double the radius, you get the diameter. So 2.25 times 2 gives you 4.5 in the diameter. And that is example number 2. Example number 3. Find the volume of the soccer ball. So here you have the radius to be 4.5. Now the volume of the soccer ball is 4 pi r cubed, all divided by 3. So all you have to do is plug it in. So 4.5 raised to the third power is 91.125. So times 4 divided by 3 gives me 121.5 pi. This is all done in the calculator. Now when you times it by pi, you're going to get 381.7 inches cubed. And that's example number 3. Example number 4 is a lot more involved because there's multiple things that we need to do. They tell me that the surface area of the sphere is 324 pi square centimeters, and they want to know what the volume is. So the surface area of a sphere is 4 pi r squared. The volume of a sphere is 4 pi r cubed divided by 3. So we need to find r so that we can go back and plug it in here. So we have 324 pi equals 4 pi r squared. We're going to divide both sides by 4 pi. And 324 divided by 4 is 81, and the pi's divide out. After this, take the square root of both sides, and you're going to get r is equal to 9. Now, I'm going to need that 9 because now I'm going to place it over here in this equation. So the volume is equal to 4 pi 9 to the third over 3. Let me fix my lighting a little bit. Okay, I don't know how good that is. Anyways, I'll just move it over this side a little bit. Lighting's better on the left. So 9 to the third power is, get that in the calculator, 729. So 4 pi times 729 all divided by 3. If I divide that by 3, gets 243. And when I multiply that by 4, I get 972 pi. So when I multiply that by pi, I get a huge number, 3053.6. And in this case, it's going to be centimeters cubed. Example 5. It says, find the volume of the composite solid. To find the volume of the composite solid, you're going to have to find the volume of the cylinder and subtract off the volume of the half sphere. So for the volume of the cylinder, we already know that the volume of that is pi r squared times the height of the cylinder. Now, we know that the volume of a sphere is 4 pi r cubed divided by 3. But because I only want half of that, I have to multiply that by 1/2. So we're ready to plug values in. The radius happens to be 2. The height of the cylinder also happens to be 2. The radius is 2. So now all we have to do is simplify. 2 squared, that's 4, times 2, that's 8. Now here, we can actually simplify without the parentheses. Why did I even put the parentheses? I have no idea. I guess it just looked nice. So the 4 and the 2 can actually divide out to give you a 2. 2 to the third power, that's 8 times 2, that's 16. So that's 16 over 3. Now, if I want the exact answer, I can actually simplify it. If I want the decimal approximation, all I have to do is just plug it in. So I'm going to want the exact answer. So my common denominator is 3, so I'm going to multiply this by 3 over 3. That's going to give me 24 pi over 3 minus 16 pi over 3. So 24 minus 16 is going to give me 8 pi over 3. So that's my exact answer. But if I want the approximate answer, then I have to plug it into the calculator. So 8 times pi divided by 3 gives me approximately 8.37 or 8.4. It all depends how they want you to round. So these are my two solutions. Okay, so this is the last problem. Please make sure to do the extra practice and the online homework. Have a good day.